Hello everyone, this is another SeismoStruct tutorial. In this tutorial I'm going to show you how to evaluate an existing reinforcement concrete structure. This is an existing reinforcement concrete structure with this typical plan, and this is the total stories: 1 story, 2, 3, 4, 5, and the core area is totally 6 stories. Then we will first evaluate this one, and then we want to retrofit using brassing system. We're adding some extra brass inside or in the parameters. So then we will evaluate the response of the straining of the structure. So we already saved this model, and you can model your own project, and then come to the SeismoStruct software, and you select building modeler, and you have to create the number of stories. So this is the number of stories, totally 6 stories. We can create some from 1 to 5th should be, we can give it 3.2 meter and apply it automatically, and the last story is 2.6. Comes to here, and you can see this is 2.6. And now we also can do some other setting, such as selecting the analysis type. So we assume the analysis type should be a pushover. We're pushing the structure in the targeted displacement, and then we will evaluate based on the given earthquake data. So the program will define the control node for us, and that's very good things. You do not need to select a specific node to apply the pushover displacement. So okay, and then we're creating the new project. You also can change the unit as well. So we already selecting meter kilonewton. So I can come to here in the export import. So my project is saved in desktop, and here called existing building, and I'm gonna open it. The unit is meter. Okay, so this is the program, this is the structure. The column is assumed 40 by 40 centimeters, typical to entire structure, and the beam is 60 by 40, and the thickness of the slab is 150 millimeter. So we're gonna selecting first column, and here in the column we wanna go to the geometry and selecting a square and 400 by 400. Because this is just a tutorial, we do not considering to change the reinforcement, so we can select as a default. But if you want to considering the some change or your own project, then you have to come here and reduce the or give the appropriate section reinforcement to the structure. So I assume this with these properties, and I'm gonna just selecting back to the view modification. I'm selecting this node, and this one here, and this one, and this one. So like this, I will draw the entire columns first. Even you can change the reinforcement in the other part. In this, the modeling area, in the analysis section also you can do it. So now we can view the 3D, and all the entire column is drawn. And the second, I'm going to draw the beams. So the same method, this is the beam, and I select geometry and using 600 by 4. And one thing that I should say, selecting the center, and do not changing the again this one, but you can change as you wish. So I'm selecting center to center, when you draw the beams from this point to this point, and the program automatically will break in the appropriate location. Now we can see again, and the beam is also added to the structure. And the last one, we want to draw the slab. Now you can considering this called insert slab. Now here is the thickness of slab, which is 150. The same reinforcement is considered here. You must select this one, this one, this one, this one. So this is the opening area, so we do not need to add it. Now we select it, modeled. We can copy these ones, copy floors. We can use the shortcut Control Alt F, this one. So first to second, and again from to third, to fifth, and to fifth, and the last one. So we're gonna go to the last one. We're gonna just go to see here. So this is the this is called view lower stories, view upper stories, and this is it. So the last stories, you can come to here. Second story is also done, third story is done, 50 story is done, and the last story is not. So we want to draw this one again here, but this time the column is same column, selecting same column, but the beam is 300 by, we can come to the geometry here, geometry, and selecting this 300 by 4. So selecting this, selecting center to center. Center to center. So the last one is we want to draw the slab in this floor. So we can go to the view, and the last floor is also completed. Now the modeling is completed. We don't have anything else because the program automatically giving some load. So that suppose this load is already giving as a superimposed load and also the living load, live load. So now we're gonna go to exit here, called exit, and we want to save it. We want to save this one because in the next step we will add the bracing here. I'm gonna call it model save. So now we are in the, now it asks me, this is Newton, it asks me how much shear force you want to apply it. So you can give any nominal base shear force. The program will automatically distribute it. So now this is 100 kilonewton. So I want to extend this to 5,000 kilonewton. Okay, and the program automatically apply this little nominal base shear to the structure. So here is the structure, and we want to perform the analysis. You can see the connectivity, the nodes, and you can see the material which is already automatically defined, but you have to get the existing material that you have used for the existing structure. Also the section, so everything. We can comes to the target for the applied load first. This is the nominal force which is applying as the base shear force, and this is the loading force which is almost 300 millimeter. We can extend this to be 500 millimeter. We can add this to 100 steps, and in the control node in the X direction. So okay, and the target displacement is we wanna considering the this code, and this is a shear building moment resisting frame, and then we apply this performance level. So this is called earthquake order level. So we have check it, this one and this one. So now okay, and go back to the processor and pressing that run analysis. So call save it. I'm gonna save EX building push, save it, and the program start to run the analysis. And with this loading and with this criteria, so structure already crashed, and you just call the yield and everything. So the structure seems and weak. So then we will improve this structure by using bracing system. So it's completed. We're gonna post processing, and in the post processing we just can see the deformation, and we want to see the target displacement or the capacity curve. So this is the capacity curve. Select on copy selection, and I wanna get a Excel sheet, and I'm gonna paste this one, paste I want to draw the capacity curve, and this is the capacity curve which we have, or pushover curve. So it has 1600. We wanna make some changes. I'm gonna here is give an equation is equal. So this is the base shear, this one divided by 1000, which we want to change to kilonewton. So I'm gonna select it again, and this column should be here. So now you can see it is kilonewton. So next I wanna make some edit for my chart area, and I'm gonna actually here is selecting this one, and we call the format data series, this one format access, and I'm gonna call 0 to 600 or 500 millimeters. Okay, 600, so it retain, and this one is also okay. We can add some design. We're gonna call this one axis. Just give me a minute to fix this one. So I have made some edit here, and this is the capacity curve using millimeter and kilonewton. I'm gonna make some other changes. This way, this one, and this one. Oh, sorry, this one. Yeah, I'm using. So we're using this one, and this is the capacity curve, and I'm gonna extend this one to be a little larger. Okay, we can also extend, make a little thinner, here is the existing structure capacity curve. So now what we're gonna do is we can save the model first, and we can take a new one, we go to preprocessor, and we're gonna call it new one. So in the new one, we go back to here and we select open an existing project or model, which we already modeled this one, and it was called existing building model. So now called OK, and the project will be open. So this is the structure. So this is the structure which we already modeled. Here is. So what we're gonna do is we wanna read it or adding some bracing. So I go to the first. This is first story. So now you should make decision which part you want to add that bracing. So let's first select on the bracing system, and this is the bracing, and in the bracing you should use which you can use X bracing, which is X method, and also you have another called single diagonal, inverted diagonal as well. So I'm going to use single diagonal braces, and which section you want. So I want to use IP section 200. So okay, 200. So let's suppose we're using this area. So when I want to add in the not in the parameter, but using in the in the center. So one here and one here, and using one here like a core area, and one here. So I can go to the 3D, and you can see the bracing system is added. It's just a single diagonal, so we want to use in inverted chevron or another method. So I'm gonna undo this one, and I'm back to here and selecting this time X brass instead of single diagonal. I'm going to use X brass. I'm going to connect it diagonal. So the same IP, and I'm going to select this one again to this one, and this one to this one, and this one, and this one. So we can go to the 3D view. Yeah, so the bracing is added. Now what we're gonna do is we're gonna select this one. We're gonna select we can again duplicate to the entire structure by going to the second floor. So we wanna delete this one and duplicate all one, or we can quickly draw again to the structure. So it's easy. Which one is easy? That's up to you. So I think the modeling is easy than copying it again. 30 stories, and we're gonna go back to 30 story and selecting this one, and here, and one here. Forward. analysis stories. And in the sixth story, just we want to add one bracing, three bracing, or so one this side and one this side and one this side. So this is just as example. Maybe it's not correct in practical, but you have to consider you're using your knowledge and your experience to model like this. So now the modeling is finished. We go back again and go resave it. So we saved again. We want to use that 5,000 kilonewtons as a base nominal shear force, and you can see we added the bracing system here like this. Now again we go to the loading path and we adding 500 millimeter again to 100 steps. Okay, and the target displacement again using the same method. So now we go to the post processing and run the analysis. And the second is called retrofitting. So this is the retrofitting building. So the analysis began, and so the concrete area is still crashing these. So we will see the response, how it works. Now the analysis completed, and we go post-processing and see the response. And you also can see the displacement is like this. We can go to the target displacement and you can see the capacity curve. This area is totally collapsed, the structure is, but the performance for this displacement is very nice, and we can select copy selection, and we're gonna paste it here, paste, and we're gonna copy this one and pasting the equation here, just bring the equation and like this. I'm adding again, select data, and I can call EX, which is means existing, and adding called ret, which means the retrofitting, and X is this the displacement. No, sorry, it should be not this one. This is the displacement. Okay, and X value is which is equal to this curve. Okay, so now we can see now here is the curve. This is the existing building, and this is the retrofitting building, which we used. We can go to rate, and we're gonna using this one, which we added bracing system. So the capacity is increased significantly, and but the degradation is in this time it will be a dropping. But the good thing is we have almost 4% drift. This is 400, and the total height of the structure is almost 1,600 centimeters, or 60 meter. So that means when we divided this 400, so it's almost become 2-3%. So let's suppose that we have 400 millimeter, which equal 400 divided by 60,000, and equal So it's almost the times equal. This one times 100 become 2.5%. So this is 2.5% drift, which means that structure has a very a huge capacity until 2.5% drift. But the good thing is that the structure with the concrete should be less than 1% drift. So the structure not allowed for the, that means the allowable drift is less than 1%. Okay, this is the end of the tutorial. If you have any question, please put in the comment and I will find time to answer you. So like this, you can retrofit and perform the seismic evaluation. See you next time.